The mass of asteroid 1 is 750,000 kilograms, and the mass of asteroid 2 is 130,000 kilograms. Assume asteroid 1 is located at the origin, and asteroid 2 is located at the point 15, -5, 10, measured in units of 10 to the 8th power kilometers. Given that the universal gravitational constant is g equal to 6.67384 times 10 to the negative 11 meters cubed times kilogram to the negative 1 times seconds to the negative 2, find the gravitational force vector that asteroid 1 exerts on asteroid 2. The equation we need for this is F equals g times m1 times m2 divided by the magnitude of r squared multiplied by, or end fraction, multiplied by r hat, where r hat is the unit vector in the direction of r. Now we can fill in a lot of this information already, so that F is equal to 6.67384 times 10 to the negative 11 times 750,000 times 130,000, all divided by whatever the magnitude of r squared is, and then multiply that outside of our fraction by r hat. So why don't we go ahead to the side and find the magnitude of r squared. Well, first, let's just note that r is the vector 15 times 10 to the 8, comma, negative 5 times 10 to the 8, comma, 10 times 10 to the 8. So that the magnitude of this squared is equal to 15 times 10 to the 8 quantity squared plus parentheses negative 5 times 10 to the 8 close parentheses squared plus 10 times 10 to the 8 parentheses squared, and that is equal to 3.5 times 10 to the 18. So substituting that into our expression, we now have a very large constant multiplied by the unit vector in the direction of r. So let's go ahead and find that unit vector, r hat. Now because we already know what the vector is, and we now know the magnitude of that, it's the square root of the magnitude squared, we can say that our vector is, open bracket, 15 times 10 to the 8 over the square root of 3.5 times 10 to the 18 in square root, comma, negative 5 times 10 to the 8 divided by the square root of 3.5 times 10 to the 18 in square root, comma, 10 times 10 to the 8 divided by the square root of 3.5 times 10 to the 18 and square root, end vector. So now if we multiply the constant we found earlier, the g times m1 times m2 divided by the magnitude of r squared by this unit vector in the direction of r, we find that the force vector is equal to angle bracket 1.491 times 10 to the negative 18, comma, negative 4.969 times 10 to the negative 19, comma, 9.938 times 10 to the negative 19. End our vector, and that is force in newtons.